how to calculate the water of crystalisation by titration. So the question is, a student weighed out that much of hydrated iron 2 sulfate, and you're given the formula, into 50 centimetres cubed of sulfuric acid. This solution was made up to 250 centimetres cubed. 25 centimetres cubed of the solution was titrated with 21.3 centimetres cubed of 0.01 moles per decimetre cubed potassium permanganate. Calculate the value of X. And you're given the equation 2 that shows how the MnO4- reacts with the Fe2+. So there are 5 steps to get the answer. Firstly, we're going to calculate the number of moles of permanganate used. Then we're going to calculate the number of moles of Fe2+ that there were in the 25 centimetres cubed that we used for the titration. Then we're going to work out how many moles of Fe2+ there were when we made it up to 250 centimetres cubed. We're going to calculate the MR, the molecular mass of the iron 2 salt, and then we're going to use it to calculate X and finish off the question. Step 1. Calculate the number of moles of KMnO4-, the potassium permanganate used. So N equals CV. So the number of moles of NO4- that we use is the concentration, which we're told is 0.01, that bit there, times by the volume in decimetres cubed, and the volume that was used was 21.2 divided by 1,000. So the number of moles of MnO4- is 2.12 times 10 to the minus 4. Step 2. Calculate the number of moles of Fe2+ in 25 centimetres cubed. So for this we have to look at the chemical equation that the question gives us, this thing here, and it tells us that 1 mole of MnO4- reacts with 5 moles of Fe2+. So to work out the number of moles of Fe2+ that reacted in the titration, because the ratio is 1 to 5, we have to times the number of moles of MnO4- by 5. So the number of moles of MnO4- is that number, 2.12 times 10 to the minus 4. We times it by 5 to work out the number of moles of Fe2+ that we use in the titration is 1.06 times 10 to the minus 3. Calculate the number of moles of Fe2+ in the 250 centimetres cubed that we originally started with, this part here. So we used 25 centimetres cubed in the titration, but we originally made up the solution to 250 centimetres cubed, so we've used 1/10 of this solution here in the titration. So to work out the number of moles that we had of Fe2+ in 250 centimetres cubed, we times the number of moles of Fe2+ that we've worked out that were in 25 centimetres cubed, this number here, by 10. So 1.06 times 10 to the minus 3 is 1.06 times 10 to the minus 2 when you multiply by 10. Step 4. Calculate the MR of the iron 2 salt. So the MR is the mass divided by the number of moles. The mass of the iron 2 sulfate at the start of the question is 2.95, and the number of moles that we had in 250 centimetres cubed is 1.06 times 10 to the minus 2. So MR is mass 2.950 divided by N, the number of moles, which is 1.06 times 10 to the minus 2, and that gives you an answer of 278.3. Last step, calculate the value of X in FeSO4.XH2O. So we know the MR of that whole thing is 278.3, and we can work out how much the XH2O weighs, because we can work out how much FeSO4 weighs, which is 151.9 from the periodic table. So the XH2O must equal the MR, 278.3, take away the mass of the FeSO4, so that's 278.3, take away 151.9, gives you 126.4. So XH2O weighs, it's got a relative formula mass, 126.4, and we know the MR of water is 18. So if we do this number, 126.4, divided by 18, we get 7, which means X equals 7, which means the formula is FeSO4.7H2O.